Here's some more problems from section 10.1. This is number 17 and 17 through 21, 17, 19, and 21, those odd problems. They want you to A, sketch a curve over the given t interval, indicating the direction in which it's traced. B, identify the requested point, and then justify that you have found the requested point by analyzing an appropriate derivative. So already wrote these up. Hope you can see these. This is just off my notes. But these were the two parametric equations, so I made a table of values, and our interval was between -2 and +2, so I graphed these, and we start over here at -2. Well, when t is -2, x is -1, and y is 2, and we're going in this direction. Right? Like I said, you could also use your calculator, and you could sketch it on this t interval, and you could trace it, and you can see that it's going in this direction also. So just put these points down, and you can follow the work. It makes sense. So for t equals -2, x is -1, y is 2, etc. for these values that I chose for t. And there's my curve, so that was the A part. They wanted you to find the indicated point. In this case, number 17 was the lowest point. Well, the lowest point, that means my y will be a minimum. So I can take the derivative and find out when that's a minimum. The derivative was 2t plus 1, and I can set that equal to 0 to find the critical values, which were -1/2. And I just did the first derivative test on y with respect to t, and I put the -1/2, and we can see that it's negative, and that's going to positive, so that's going to be a relative minimum for my values of y. So it was a relative minimum, so that's actually the C part. And once I found that value for t when t equals 1/2, okay, when t equals 1/2, or I'm sorry, -1/2, excuse me, t was -1/2, pardon me. So when t is -1/2, if I put this in, I can find my values of x and y. If I put -1/2 here, I get -1/2 plus 1 is 1/2, and if I put -1/2 in here, I get 1/4 minus 1/2 is -1/4, so there's my point. Okay, and that was the point when t was -1/2. That's the relative minimum for dy dt. And just put that back into the parametric equations to get the points. All right, and I hope you can see that. Okay, let's take a look at number 19. And again, we had this graph here. X equals x equals 2 sine of t, y equals a cosine of t. So I put the values in. I used quite a few values here. And these were exact values, so we could use for a unit circle, just so we could do that. And then I did actually change them to decimals so I could graph it a little bit better. So these are all the points I had. I said pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3. So these are all exact values you can get from your unit circle. You can see these numbers look familiar. And then found the y. Accordingly, the same thing, y is cosine. So it's easy to find with these exact values. And we can see that it was going from this direction. I started up here at x equals 0, y equals 1, and it goes this way. So that was the A part, was to sketch the graph, and there's my table of values. The B part, they want to identify the requested point. This was the rightmost point, So that means that x will be a maximum value, a relative maximum. So I just took the derivative of x with respect to t, and I want to find out where that's going to be a relative maximum, so I graph this. And, well, first of all, I set it equal to 0, and that's going to be equal to 0 when 2 cosine of t will equal 0 when t is equal to what? Well, the cosine of 0 is 1, so it's going to be pi over 2, because the cosine of pi over 2 is 0. So I got t equals pi over 2. And you can see that it's increasing. We just put some values in here. It's decreasing. How can you tell that? Well, you can just look at the cosine curve, and here's the cosine curve. Even though it just has an amplitude of 2, it's still going to be starting at 2 and being 0 here, and then negative, so it's going from positive to negative. So you can look at the cosine curve, and you can get an indication that you're going to be going from positive to negative. So it looks like I'm going to have a relative maximum. So we have a relative maximum because x changes from positive to negative. Remember our techniques using the first derivative test. So that's when t was equal to pi over 2. So that's the appropriate derivative. That was actually the C part. And then if you put this in, we can get the indicated point. So if we put pi over 2 here, okay, the sine of pi over 2 is 1, 2 times 1 is 2, so that's my y, x value. And y, the cosine of pi over 2 is 0, so there's my point 2, 0, and you can see that makes sense over here, so that's the rightmost point. And that was the b part, actually finding the indicated point, that's the rightmost point. Okay, and then number 21, take a look at this. And this was 2 sine of t, and y equals a cosine of 2t. And we want to find the highest point. So the highest point, well, so we're going to look for a maximum of y. So if I take over this interval, now this was the interval. Again, this didn't mention that, but this number 19, the interval was from 0 to pi. That's why we had all these subdivisions in there. And now we want the in this interval from 1.5 to 4.5. And we're looking for the highest point, so we're going to look for the maximum of y when we can maximize y. So we take the derivative of this, we get negative 2 sine of 2t. The derivative of the cosine is a negative sign. And we want to find out where we have a 0. And you know it's going to be 0 when when it's 0, of course, but this is not in the interval. So when t is 0, that's going to give me a 0. It's also going to be equal to 0 when t is equal to let's see, pi over 2. Well, it's a little bit hard, so let's just graph it. It's easy to graph because the period is going to be well, look at over here. Remember, the period is 2 pi over b. b is 2, so the period is pi, so I can graph my derivative. Now remember, it's got a negative, so that means I'm going to flip it. So instead of going like this, it's going to go like this. And I'm going to have an amplitude of 2, so it's going to go up to positive and down to negative 2. But I'm going to go upside down, so I'll start here. And remember, the sign is 0, 0, and it's going to go like this. And remember, the period is pi, so when I get to pi, 3.14, I don't know if you can see that. That's 3.14. It's kind of cluttered here. Then that's one cycle. Okay, so that's 3.14. And this is 6.28, that's 2 pi. So we go through this whole 2 cycles in 2 pi. Now this is kind of between because this is 1.5 and pi over 2 is 1.5. Or yeah, pi over 2 is 1.57 because pi is 3.14. So I'm starting a little bit to the left of this, so I want to really see what's happening in this interval here. And it's going from positive to negative. Here it's going from negative to positive, but I'm not worried about that because I'm looking for a relative maximum. So it looks like it's going from positive to negative. Positive, negative, so I have a relative maximum right here at pi. So I have a relative maximum at pi. I kind of analyzed that without actually doing a first derivative, just looking at the graph of my derivative. And the derivative is negative, then positive, then negative, then positive, because this is the graph of my derivative. Rather than trying to set it equal to 0 because I have some other possibilities for it to be 0, I just looked at the whole thing. So this makes it a little bit easier. So I have a relative maximum at pi because the derivative changes from positive to negative. So this is analyzing the appropriate derivative as they asked. And what's the point? Well, I just put pi in. My values here, so I've got 2 sine of pi. Well, the sine of pi is 0, so that's going to be 0. And then the cosine of 2 pi, and that's just going to be 1. So there was my point, and you can see it makes sense if you look at your graph, 0, 1. Now when I graphed it, no, I probably didn't go over the graphing, but this was, I just did the table of values when I graphed this. And from 1.5 to 4.5, so I did the values over here. You can see all the values, and you can just put those in your calculator if you want to get these values. And you can see it looks like right around, it looks like I'm peaking out over here. I'm negative, negative, and then I'm going 0.28, then 0.96, and then back down. So it looks like I'm peaking out right around when t is 3. Well, that's pretty close to pi. So right over here when t is, it's right around here, it's peaking out. It looks like I'm starting at this direction when it's 1.5. X is 1.99. So over here, so it looks like I'm going in this direction. So if you look at your table of values, it looks like this is the direction that I'm going in. So again, we just did our table of values and put these points in. Again, you could always graph with your calculator, but this is a little bit more, you know, showing that you do have a basic understanding of how to graph these things. And you could, like I say, look these values up in your calculator. Thus, the sine, when t is 1.5, 2 times the sine of 1.5, and then the cosine of 2 times 1.5, or the cosine of 3, and then you should put these in, and you should get these values. They should check out. If you have any questions, please check with me in class. So this is how we can graph this. And then it does make sense. My maximum is actually over here. It is actually the point 0, 1, right at 0, 1. Okay? So I hope that gives you some kind of an idea of what we're going on with those problems.